Hi folks, this is about the nature of quadratic roots. So this b squared minus 4ac, that's a thing called the discriminant. So you don't really need to know the word discriminant, but it comes from, you'll recognize that it comes from the formula, the minus b formula. So this is the formula used to solve quadratic equations. And so you can see straight away that the discriminant bit there is the bit that's inside the square root. So if we're looking at a quadratic equation, and I'm looking down at these here now, so if the b squared minus 4ac is greater than 0, well, it has two distinct roots. So if it's equal to 0, it has two equal roots, and then if it's less than 0, it has two imaginary roots. And then the last one is if it's a perfect square, well then there's rational roots. So we have to understand why each of them is. So if you were to think about it, if you were to take a quadratic equation and you were to just put everything in, and then inside here, inside the square root, you're to get a positive number, well then it's just going to be normal. You're going to get a plus value and a minus value, and then you'll obviously get two roots. So that's why you have two different roots. So that's generally the way it would have worked out for you when you were doing it before. If the b squared minus 4ac is equal to 0, so the second one, so if you were to imagine if in here you got 0, so if that was 0 in there, well then that would almost get rid of the plus minus, and all you're left with is the minus b over 2a, because it would just be plus or minus 0, so it wouldn't actually give us two values. So that's why there's two equal roots. And then if it's less than 0, so if you have a negative number in here, well then really you're being asked to do the square root of a negative number, so you can't really do that. So it's two imaginary roots, and that's where the topic of complex numbers comes in, but you might not have done that yet. But basically you need to know is that it doesn't really have real roots. It's just they're imaginary roots. And then the last one, if that inside is a perfect square, well then it's rational roots. So example then, so you're going to be given quadratics in here, and it'll always mention roots in the question. So if we're to look at these four here, so if I was to do a, so all we're really doing is we're just working out what b squared minus 4ac is. So remember, the a is this thing, the b is in front of the x, and then the c is the last part. So b squared there will be 5 squared minus times 3 times minus 1. So that's 25 minus, well, it'll be plus 12 in the end. So we get 37. So therefore, we can see that obviously that it's greater than 0. So if it's greater than 0, well then it has two real roots. So it has two real roots. So look at the second one. So b squared minus 4ac. So there you'd have 42 squared minus 4 times 49 times 9. And we're actually getting 0 there. You can use calculator to figure that out. So because it's equal to 0, it has two equal real roots. Part C then, we'll just do it up here to save space. So we have 2x squared plus 8x plus 9, so therefore b squared minus 4ac would be 8 squared minus 4 times 2 times 9. So that's 64 minus 72. So we get minus 8. So therefore, because it's a negative number, And if you think about what it actually means, so if you were to get a negative number in there, you're getting a square root of a negative number, so it can't really be done. So it has no real roots. Or but it has imaginary roots, so you don't need to know much about that yet. But that's a different topic altogether. So imaginary roots. And then the last one, so part D. So there for b squared minus 4ac, that is 7 squared minus 4 times 2 times 4. So we're getting 49 minus, and then 8 fours are 32. And so we get 16 there, sorry, 17. And 17 is greater than 0, so because it's greater than 0, it's like the first one, it means you're just getting a natural number inside the square root. So it'll have 2 real roots. Right. Okay, so find the value of k so that it has equal roots. So if it has equal roots, if you look back up at the orange box up here, so equal roots is the second one. That's where the b squared minus 4ac is equal to 0. So that's where we're going to do b squared minus 4ac is equal to 0, because we know that, because it's what it's saying, it's telling us, we know straight away that it has to be equal to 0. So therefore our k squared, so k is the b here, minus 4 times minus 8. Sorry, it's yeah, they've rearranged a little bit here actually. So I could rewrite that quadratic as minus 2x squared plus kx minus 8 is equal to 0. I don't know why they rearranged it, but you can see that the a will be minus 2 and the c is minus 8. So equals 0. So k squared, it'll be minus 64. Is equal to 0, and you can see then that that's difference of 2 squares. So k plus 8, k minus 8 equal to 0. I'm just factorizing it by difference of 2 squares there. And then k is equal to minus 8, or k equal to 8. And that's it. So we've used the fact that it has equal roots to work out the value of k. Right, if you want to attempt these yourself, you can just pause the video and play it on then, and I'll go through the answers. So it's just practicing using the b squared minus 4ac. So first one, it would be, now here there's an automatic 1 in front of the x, so it's 1 squared minus 4 times 2 times, they're all positive, so 1 minus, and then it'll be 8 times 5, so 40, so minus 39. So that's less than 0, so it has no roots. And it has imaginary roots. So and b squared minus 4a, the second one, so we get b squared minus 4 times minus 2 times 1. So that's 9 plus 8. So that's just 17, so that's greater than 0. So that has 2 roots. 2 squared minus 4 times 3 times minus 1. So that's 4. And then it'll be plus 12, so that's 16. Now for the last one, because 16 is a number that's a perfect square, so if you were to get that as the discriminant in a quadratic, well, really you're getting a 16 in here, so this is 16 in here, so square root of 16 is 4, so you get minus whatever b is plus minus 4 over 2a. So therefore it has rational roots, so it's a perfect square, so it has rational roots, so it's the number 4 there really that we're looking at. And obviously it's a positive number as well. So it has